probe coming off. Keep flow probe off.
As predicted, the Granella did not get very far. So we have all boxes free, right?
Okay.
Right. We can put it into the big one.
Yeah, it's so soft in there, right? Yeah, it's kind of
Where would you like it?
stuck sometimes. Okay. And bring the camera in.
See the size again. Okay. Sure.
It's still pretty messy.
It's messy, yeah.
Like there's more going on here than
Hi. How's that view? You can kind of see it goes in there, I think.
It's a little warmer.
Slides in the red. Yeah.
It's station, dude.
Good station. The science camera is no use to you. It's a data in the back. Awesome.
Right.
I mean, I can bring it out and see if I can get any kind of view for you.
Whatever you feel safest with, I think. That is it.
That's about all I got anyway.
Yeah. Get there.
There is something.
There was something.
You're just under underneath it.
Right. I'm gonna copy all the data over again because I shortened a few of the files. They're fine for this, but in terms of like saving the files, I'm gonna go ahead and copy everything over again. And then that'll be the official record. Cool.
Well, we did it. It happened.
Okay. They're in there supposedly a magnet
Oh,
there
okay.
somewhere. Like right
Let me just
about
back
there.
up the data.
Yeah.
You're right.
Set it down. And be good.
Okay.
Let
I
it
think
go.
it'll leave all this stuff up again. Still up.
Yeah. Okay.
Yeah, I think so.
Oh, we got it.
We grabbed
Yeah, you got
the data sheets too,
Yeah.
and we should photograph those and then make digital copies.
I think it's hit the magnet there. There it goes. I saw it just grab on. Yep, right there. That should be good. Okay, I'm gonna go ahead and retract the science camera. Not to be much use to you there, but. Your head's top of the bottom box.
Yep.
Okay.
Just about there. I think you got it there. Yep. Not closing them.
All right, I'll leave you with the rest of this. Thank you.
Thanks, Andy.
Where are you
Oh,
on?
yeah. My pleasure.
Thanks,
Thanks for the
Lou.
opportunity.
Yeah.
Yeah, I'm excited for the
Long
octopus.
day.
Long day.
We had a long day. So, Rua Kiba and Andy Fisher have been in the control van since basically like 8 books and specimen. Some biology, rock, and core collections.
You got it. I think it's just right on the end. Yeah. Broke the tire out.
That's a start.
Hopefully that helps a bit.
It does. See if I can stand it up a little bit before I grab it.
Yeah, it's just right on the edge of that milk crate. That's the problem. There you go. Nice. Yep.
Get this lined up. Grab it.
Yep.
It's better now.
This is some pretty insane looking at Is this the one we've been using the whole time? It looks
Yeah.
new.
I think this is the only,
Yeah.
this is
Are you
it.
happy with that grip? You got a pretty decent grip on it, actually.
I'm
Yeah.
flush on that, so this
Okay.
might, and then we can go ice cream scoop. Woo. Okay.
Alright, I'm gonna go ahead and retract the port.
Alright.
Lowers off.
This is ready.
Alright.
Okay.
I think he's out there in the distance, just to the right there.
Okay.
Send us back out.
I'm gonna pull in some of our usually got
Oh yeah, over to the
almost
right.
90 delta right now, so if this yanks you, let me know.
Alright. Let's go see what we can find.
Let's go find the altitudes.
It's just to the right. In the distance.
Okay.
Yeah. Ooh. With a monopsid isopod walking by. Can I do a quick zoom on the monopsid? Or is that problematic?
No, you go ahead. I'm using the other camera to fly towards the octopus right now.
Oh yeah, look at this bad boy. Or girl. Oh yeah. Look at those legs. Wow. Also looks like he has a hitchhiker, a parasite, something. Those like the weird like non,
Very spider-like.
the weird thick floppy one. That's, I don't think that's supposed to be there.
Huh.
Customized.
Wow, you can, I think he's having trouble walking because of how strong the current is.
Oh wow.
Man, it is really going down there.
Yeah.
And he's a pretty big guy as well.
Yeah.
If you were to spread out those legs, wow. It's like, yeah. That'd be a good 40 centimeters across, leg to leg. Interesting. Okay, sorry.
That's
Let's
all right.
proceed.
Yeah, no problem.
I wonder how often the currents are this strong here.
Do we need to get zooms on them, or?
We do. So, this is great. Here you're getting all the frame grabs, right? I'm gonna do some zooms for you. Tell me if you want anything different. You just see the what? Reproductive arm. Okay, sure. So you can just see the reproductive arm here. That's max zoom for you, so hang on a second. There you go. Oh yeah. Was that enough? Okay, great. We are good to go.
So now we're going to sample.
Yes, please. And I think we should put into BioBox 2 because that's a single BioBox, so we won't open again once we put it in.
Alright.
Maybe a little bit closer if you can.
Sorry about that.
Yeah, that should be sufficient.
Alright, come down, try to set down.
Oh, in opposite spots, swimming away.
Okay. Stopped. What do you wanna see? Advice here? We're gonna try and go from the top? I don't know. Never sampled one
He's gonna
before.
swim, so,
Okay, is he gonna try and come up or?
Oh, yes.
Okay,
so you can try to go over him.
okay.
We were just kind of gonna.
Yeah.
But if he darts, will he dart this way?
I don't think he's gonna dart, he's gonna try to crawl.
Okay.
Don't make any,
Side movement?
yeah, if he
Okay.
starts moving and he's coming out, don't push him harder or faster, just let it happen and then go chase.
Okay. So not chasing with the net, chasing with the ROV.
Yeah, like, you go down and he starts coming out, don't just go at anchoring and let that break.
Okay.
Corral.
Yeah, try to do that, if you can do that, great. Here,
Woo.
you
I mean, we can use different words. Corral, woo.
Woo it, coerce.
Woo.
Yeah, just.
No, not coerce.
Yeah, no. Suggest it.
No.
Ultimately, probably gonna have to.
No, I think you're just throwing
Throw some more
words.
science out there.
That can-
Is he gonna come off the seatbelt? Okay.
Oh, kind of doing parties here. Waiting.
Weights behind it.
How many push scores? How many? Do you already want 6? Okay. Let me write it down. Times 6. If anything, what we can do is we can do, since we're settled down here, we can do the push scores next. Because
Gets me out.
I only have 15 minutes left.
Just a little bit more, see if I'll come into it.
And so then we do the push scores.
Yeah, that whole fucking thing.
Yes. And then by that time, Leo will say, once we're done, there was any kind of people. Oh.
Just let him crawl into it.
Okay.
Just hold what you got right there. See if he crawls in, if he tries to crawl out. Cool. Their arms moving a little bit.
Okay, this was the easy part, I think.
Start rotating your jaw counter or clockwise while you bring it towards us.
So I'm just pumping
Mm.
in front.
No, the back. Rotate.
Swooping up.
Yeah. Jesus.
Going back towards us.
Yeah, because he's in there right now. So
See, it's hanging out the side a little bit now.
So all of the specimens that we are collecting during these 2 Octopus Odyssey research cruises, they are all biology specimens are going to be housed at the Zoology Museum at the University of Costa Rica, Universidad de Costa Rica. This is the first time that many of these species are being collected in Costa Rica's waters, or potentially ever. So many of them, such as this octopus that we're collecting, are, again, new to science or a new record or a range extension for Costa Rica. So this is all really important. These samples are all absolutely critical for allowing Costa Rican scientists to understand what lives in their waters and potentially how best to manage it.
Towards the end of the bag.
since June to the December cruise, Janet Voigt, who is the world foremost expert on deep sea octopus, she has been working with Fiorella Vasquez, who is in the RV control van with me right now, and they have been working on all of the octopus specimens that were collected during the last Octopus Odyssey expedition in June. There's some really exciting potential hypotheses coming out from that work, in that they think they have several new species of octopus from within these expeditions, these few sites we visited. So over the coming months after this expedition, they'll be working to describe those species, formally describe them, which means looking at the morphology, the body, the features of the body, as well as doing molecular work, so looking at the DNA and putting those two puzzle pieces together to then truly determine whether this is new, and if it is, then describe those new features and give these octopus a name and really introduce them to the world.
Start porching out. Porching out. Lower's coming on. Which file box are we trying to go in with then?
Let's go with Firebox 2, please. And then we're not going to open that one again.
Okay.
Janet says, good job, guys.
Yeah. File box 2. Open. File box 2 is all the way open. Now we'll work.
Great work. Well done, guys.
Good job, Tyler. Thank you, J-Rock.
That was great. Okay. Any thoughts on what we'd like to collect next? We are just in full sampling mode right now. Yes, understood. So what would you like right in the next 10 minutes?
No, I mean.
Oh, I think-
in the next shift.
Yes. So, but there's 10 more minutes. So,
Yeah.
could these be more fossils? What's this thing? Corallimorph?
Good job, buddy. You just tell me where you want to go next.
I mean, the world is our oyster, really. We can just have a little drive around, see what we see. We're really looking for echinoderms. What does the map look like? Let's have a look at the bathymetry. Yeah, so I suggest we just continue climbing. Let's see how whether we hit any outcrops, but we're really looking for echinoderms. And before we head too far up the hill, we do want to collect, not just quite yet, let's get some other things, but we do want to collect 6 push spores. But let's see what's around this little area before we do that. So just continue ahead.
Just trying to follow
Please.
the same track line.
Yes, please.
Alright. Just gonna get myself lined back up with that.
Just like I lined up for you.
Thank you.
If you guys see anything that you are interested in, shout.
Starting our way up the hill.
another like gang of mating. Whole bunch of things happening there. Some corallimore, some sea urchins, brittle stars, sponges.
We're gonna head continue on to the northeast looking for some of the sample, but you're basically gonna move.
What's this big thing over here? Oh, black coral. Lots of little ophiuroids. We're keeping an eye out for, we have a hit list of, it's not a very nice way to put it. We have a list of samples we'd like to collect, biology priorities. On it includes several species of sea cucumber, some stalked crinoids, some sea urchins. Basically species that we may not have had collected before. Do we want a diamatidate? Not a diamatidate. One of the aspidodiamat. Can't speak anymore. One of these little sea urchins here, or the cuke. Keep going. Let's keep going. They weren't convinced. I've learned that the Spanish word for cucumber is pepino. Pepino. Which I unfortunately keep confusing with the word for popcorn, which is palomitas. So I keep asking for cucumbers all the time. Palomitas or palomitos? For popcorn. Palomita.
Little dove, is that what that means?
Do you want to look at this sea cucumber over here, Sergio?
Left.
Yes. Okay, if we could have a look at this purple sea cucumber in the distance, please. This buddy boy. Yeah, exactly, that one. Did we collect this one already? Yeah, okay. We suspect we may have collected this one on the last expedition. On the tiny little rocky outcrops in these areas, or rocks, we are seeing a lot of these black corals, a few of these black corals here, some particularly big ones. Some sponges. Oh, I think I see a cucumber in the distance, potentially. Oh, here? What about this guy coming into view? Cycropodium semperiana, long Dakota. How do we feel? Did you collect this one already? Yes? Yes, you collected already?
Yeah, that's nice.
Okay, what about this purple one on the left? Sorry, what about that one? Can we have a look at that one quickly? What about this one?
Can you do a zoom?
Yeah.
It seems mentolitis.
Yeah, I think this is a Benthidites,
Yeah.
sanguinolenta. Yeah.
Do you have this before?
Did we collect this last time?
Yes.
Okay, let's keep going. You know the drill. You see all the sea cucumber species that, or morph species that you have not collected yet, and then when it comes time to collect, only the ones that you have already, you've collected already. Okay, there's one coming up, but that might be the same. We are able to, we are permitted to collect black corals, but we did collect quite a few last time, and so therefore had specific black coral requests that we were looking for. We are trying not to collect multiple of, or many individuals of the same species, just because it's could be better to collect something that we haven't collected before. So we're on the lookout for specific black corals, but not all. Another one of these giant Cycropodes. Let's keep moving. Oh, it looks like there's one coming up here. What about this thing? It might be a slime star, actually. Slime star. Is this the same one we have? Yeah, so in terms of black corals, we do actually have, there is a scientist at the Zoology Museum at Universidad de Costa Rica working on black corals, and her entire PhD is going to be working on many of the samples from these expeditions, which is really exciting. Her name is Wendy Matamoros Calderon, and she was on the June expedition, some of you may remember, but this time unfortunately couldn't join us. But I know she's watching from home and is very excited about every black coral specimen that we've been able to collect for her. What about this guy? Coming up, purple guy. Psst, Echino's. What about purple guy? Same Benthidites sanguinolenta. Okay.
No sanguinolenta, but
Another one.
I think we got it.
Last time, okay.
The Venturia that we are looking for
Is yellow.
is the one which has long filaments in the one of the extremes of the body has long filaments.
Okay.
Yeah,
Purple?
And it's purple also,
Okay.
but don't have this big papilla.
Okay.
Can you check this star?
The Brazingid? No. The white one?
Yeah.
This one.
No,
The Brazingid. Okay. Thanks, guys. Apologies.
It's the same Brazingid that we collected yesterday.
I mean, it's a different color. This looks like a Friella.
And it has less arms. Maybe it could be different. What do you think?
This looks like a Friella dude to me,
Okay.
which I don't know if that's what we collected yesterday. I mean, it's a different color. Does that indicate anything? Would you like it? Yeah?
Yeah.
Guys, are we able to collect this?
Sure. How do we typically collect? How do you typically collect them before? Was it?
So I think this one seems to be attached to this tube. So if I were you, I would try to just grab below the, grab like down here, and then just bring the whole tube and sea star into the bio box potentially.
Okay.
But I mean, you guys are the experts here, so
Since it's two things, it's a tube and
We don't. I mean, we're not that bothered about the two. We just
Okay.
it could just be a vessel for bringing the sea star
Right.
easily.
This might be
So this is like a brisingid, which is a type of sea star, potentially from the family Phragelidae. Oh, where's it gone? We did collect a brisingid on the dive the day before yesterday. It was our first brisingid we've ever collected on these expeditions, but it was bright orange. So this could be, oh, I see Wendy's joined us in the chat. Hi, Wendy. So this could be a different species.
I think the port arm. Yeah.
So we're going to collect it. Oda. Sorry, I did this the second time. Are you talking now?
Happy with that deal?
But I want to go exercise. So would you be able to sit me on some for? Okay. Perfect. Thank you. So. I'm going to be handing over to Oda Liscabridi again. Oda is a general octocoral wizard from the Universidad de Costa Rica, and she's going to hold on for Randy. Oop, Polly keep coming out of the... Oh, yeah, great sample then. Woo! Oh, no. Oh, he jumped ship. Okay. So Oda's going to be holding on for Randy until she is available. And until then, oh, Rachel's there too. Oh, hey, so we have two of our June expedition participants joining us in the chat, Wendelin and Rachel. Great to see you all, and that you are following along despite having probably many better things to do at home. So with that, handing you over to Oda to continue doing all the collections. So we can put this into a small bio box, I think. So BB1AB or BB3AB are all open. Any works for that?
Give me 1A.
Send the porch out.
Sorry, this box just hasn't been labeled.
Oh, so it's 1A, right?
It's 1A,
Yeah.
On the sheet it's 1A.
Yeah.
We'll get that swapped out.
Okay, move on, thank you, Oda. Good luck. Thanks, guys.
Yeah, you Oh, it froze it. I was just trying here to grab the next box. Put to the left of it. Left. Good there.
Hey everybody, it's Sophia here, just checking in. I'm your multimedia technician. We're just having a little bit of a watch change going on before dinner. How's everyone doing? And now we have Odaliska. She's gonna be leading us this hour.
Thank you. I was gonna talk to you about it. Thank you.
Yes, okay.
Anywhere works.
Yeah, no.
Yeah.
Where do you want them?
Anywhere
Right?
works. Yeah.
Okay.
Thank you.
Y hola a todos de nuevo. Vamos a, we are going to collect the push course here. Here. Yeah.
Okay.
Right here. En este momento vamos a recolectar unos núcleos para varios estudios geológicos y microbiológicos. Si quieren dirigir eso, ¿no? ¿Todo bien?
They know what they're doing now. Just push course. I have a special one down there that has drill holes and that's it. So I'll be getting geochemistry too. You know the drill.
All 6 guys?
Yeah, all
So
of
they're
them.
all 8?
Los 6 aquí, sí.
Yeah, let's do 6, right? Save some
Sí.
time. 6, but including the drill one.
I believe that's in position.
Up front, 1 or 2.
It wasn't 2 when we left last night.
Okay. Yeah, pretty sure. I think
Sorry,
6
position 5.
would be good. Save you some time.
Okay, 6 here.
Do you want it all the way out or is this good? Where do you want it?
Aquí está nuestro colega Gustavo Ramírez tomando una decisión sobre dónde vamos a recolectar los núcleos. Él es microbiólogo marino y está trabajando con algunas de estas muestras.
Scattered in this area, guys?
Hi everybody, in this moment we are going to take some push course for geology and microbiological work. Here is the colleague Gustavo Ramirez who is going to work with those of these samples in order to analyze the microbes that are there in this interesting sediments. And also Maria Sandoval is going to work with the sediments themselves in order to find different organisms that live in this interesting substrate.
Do we need to be somewhere you can just put it out front here or something?
These are, I've only
Bueno,
done 2,
un push core o un núcleo. Estos se llaman nucleadores, los push cores, porque lo que hacen es introducirse dentro del sedimento y por medio de una válvula que hace un vacío, entonces se jala una cantidad de sedimento que tiene cierta estratificación y luego eso es lo que se analiza, pero en el orden en que está en que sale la muestra, en el orden en que sale el sedimento va a tener como una diferente estratificación y es importante mantener esa estratificación. Y porque digamos lo que va a salir en la parte superior es lo más nuevo y lo que está en la parte inferior es lo que está más viejo en el sedimento.
I got a pre-drill one, so I can stick rhizomes.
It sits there. That's the only thing I think of.
Yeah, it's either that or do it one at a time. Press, bring it back in.
And I think you're gonna set them all in.
These push cores are used to suction an amount from the substratum, and it has a kind of valve that do a vacuum. So when they put the core in the sediment, they can get a column of sediment, where the older sediments are in the bottom and the younger sediments are in top of the nucleus. So this stratification is very important for the studies that the colleagues Gustavo and Maria do with these interesting samples.
Probably half an hour. It'll be 1, 5, 2, 6, 6, 7, 8, just perfect. Thank you.
Ready, Randy?
Yes, thank you.
Ahora los dejo con la colega Randy que va a seguir transmitiendo. Bye everybody. Now you will be following the transmission with Randy, our colleague.
Thank you very much. Thank you so much, Oda. Hi, everybody. You know what you're doing, right? We're in the middle of an op. I am late to my shift because I was in a COBRA meeting. COBRA is not a snake. It stands for the Crustal Ocean Biosphere Research Accelerator, which is a National Science Foundation funded program with 5 co-PIs, all of whom are here on ship. It's very exciting for all of us to be here together. And one of the things, COBRA does many things related to the Crustal Ocean Biosphere, which is actually the habitats that we have been diving in this whole cruise. But what COBRA is doing, among many other things, is hosting webinars, which are open to the public. So you can go to the COBRA website and check that out if you're interested. And we also run a bunch of training opportunities for scientists who are going to be leading expeditions. And we do a bunch of other things to try to enable and create a network of networks across the deep sea community and the Crustal Ocean Biosphere community. So it's pretty great. So COBRA, deep sea cobras, just in case you didn't know. I am Randy Rogen. I am a professor at Boston University and also lead the science program for the Blue Nature Alliance. And I'm part of COBRA. We are in the middle of taking some sediment cores. We're taking 6, so we're setting up to do that, right? We haven't taken our first one yet? Amazing.
Just a
Little housekeeping, little getting everything ready, popping the tops, so that makes it nice and easy for the ROV Sebastian to be able to boom, bang out one sediment core after another, which is pretty awesome. And Gus Ramirez, one of my colleagues from Southern California, who's here on ship, is very excited about working with Maria Sandoval to look at all of this sediment later on today. So it's been a lovely tour through the sediment, don't you think? New octopus species, lots of little crustaceans, some pretty rad echinoderms, all kinds of interesting xenophyophores, just great stuff in the mud. Oda's laughing at me. She's allowed to laugh at me. She can laugh at me anytime she wants. What? No corals. Yeah, Oda and I are both coral biologists. And so for us, we are always looking for corals. But the truth of it is that some of this mud is probably made up from dead corals. Probably.
But if we find some rocks, maybe we can find some
Oh,
attached some.
look at that.
Something.
Or sea pens. There's been some. Occasionally.
Leave them there.
Yeah. I'll leave the sea pens. Let them be. So yeah, Oda brings up the excellent point that where there are rocks, there are corals. So a lot of organisms use hard substrate to attach to, and some of them are completely adapted to the soft sediment. And so looking at the difference in these communities is really striking, especially since often they're right next to each other. So, sometimes a few meters makes a big difference.
There you go. Nice. Snowstorm. Yeah, it's not light, sorry.
Oh, it's not the spot, right? Because without it, it's all black out.
Alright. I'll just push your receiver.
Okay.
Thinking about how you're gonna have to put it back,
Yeah.
So I don't know if any of you have ever been muck diving. Indonesia has great muck diving, like in shallow water on scuba. But we find some incredibly cool animals completely adapted to the muck that are different from anything else around. And Indonesia is like the hotbed of shallow water biodiversity, the Coral Triangle on the planet. It is absolutely the most biodiverse spot in the shallow ocean. Phenomenal. And one of the things that you're on the coral reefs, and it's like being a kid in a candy store, right? Like everything is new and shiny and exciting, and you want to just explore and play with all of it. Not eat it, but But when you go muck diving, right, it's a completely different experience. But the biodiversity is a little lower, but the animals are so unique and amazing, and they're just incredibly cool. And muck diving at night is taking it even to the next level. So Raja Ampat in particular, which is in the Bird's Head region of Papua, is, I mean, absolutely stunning. And the muck diving there is off the hook. And whenever we're going over these sedimented areas, I really think about that comparison. I always sort of have Indonesia in my head as I think about the difference as you transition from reef to muck. Completely different communities, both equally amazing in their own way. And here we're going to do kind of the same thing, go from sediment to rocky outcrop, and you will see the communities change. And if you're new to hanging out with us here at the Schmidt Ocean Institute on our Divestream, you will be probably and you've been with us all day and you've seen the sediment, then you'll be able to see this transition, which is very abrupt and extremely cool. So I have Theo in the back, who is an octopus expert, and you probably were pretty excited to see that male octopus earlier, yeah?
Yeah, that would be the other type.
That's going to be the holotype species. Has anybody talked about holotypes yet over here? No. Okay, so we collected a very cool male octopus. We were joking in the back that, you know, it has sort of like a Muppet-esque quality to it. We think. Theo probably thinks it's very elegant, but we think it looks kind of comical. But something is fish. Okay, fish shadow. We're taking this awesome push core. It's happening. But this octopus is great because it's the male octopus of a brand new species. We have Janet Voigt with us on board too, who is very excited about a new species. And what's cool about collecting the holotype is that is the specimen that will be used to name the species, and so it will become a museum collections piece that anytime anybody forevermore wants to compare a species that they think is this species, this is the individual that they will compare it to. So that's what a holotype is. And so when you have a holotype of a species, it's the most famous one. It's the one that gets to like really truly define its species for the rest of the world forevermore, for time. Pretty cool. Yeah? Did I get that right? Anything else I should add about holotypes? Covered it? Yeah. Cool. So wherever you go to a natural history museum and you see the word holotype next to the collection, you know that is the standard. It's like the kilogram, right? Like there's 1 kilogram that defines all other kilograms. Where in the world is that kept? Does anyone know? Paris. It's kept in Paris. There you go. And all other weights and measures, right, are based on the weight defined by that 1 kilogram of whatever material it is. It's a metal. That's the holotype kilogram. And this will be the holotype octopus male for that species. Learn something new every day. Thanks, Sophia, with her Paris kilogram knowledge. Do you know what it's made out of? Is it iron, steel? Titanium? I don't know, but it's some kind of metal. There you go. Maybe, something for all of us to Google one day. So we're making an array of push cores, and this is pretty cool. I have not seen this done before, but we are doing it right here, live for you. 3,077.7 meters below the surface of the sea with ROV Sebastian with the Schmidt Ocean Institute. And the reason we're doing this is so that each of these push cores will be analyzed in a different way, but from right next to each other. So we can kind of get an array of data. So you can look at it for microbes, you can look at it for minerals, you can look at it for chemistry, a number of things that will all be able to be cross-comparable and cross-correlated because they all come from the same area. And that's not an opportunity that we often get to be able to, A, have all those different types of expertise on board, and B, to be able to have this many push cores from one area. So we'll be able to use really the full capacity of the Falkor 2, which has enough birth spots for quite a few scientists and a whole diversity of expertise. And be able to use these push cores as an opportunity to really showcase the range of that expertise by using each push core for a different analysis from the same spot. here you have it, folks. Push core array in progress.
When you go overboard, oh, okay. Yeah, you gotta swim outboard a little bit more. Yeah. There you go. Yep.
So every time I watch Sebastian do something this intricate, I'm always reminded of how incredible what we're doing really is, right? We have two amazing pilots. I think we've got, Tyler on the hand right now, who are manipulating this robot, this tethered robot, which is bigger than a car, right? 3,000 meters below the surface of the sea. And, using hands that are not our own, to be able to do something pretty intricate, right? To be able to pick these up and push them into the sediments and then be able to pull them back up is, if you could do this with your own hands, this would take, 2 minutes? But doing it with a robot hand, the engineering in this is really amazing. The dexterity of the ROV pilots who are actually maneuvering the camera, the vehicle, and the hands at the same time is also pretty amazing, all while monitoring. There's a million screens in here. Hang on, let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9. 24 screens, many of which have split views where you can see a quad of screens, or sometimes even octo screens, since it's an Octo Odyssey. You can see 8 screens at a time on one screen. So 22 screens with multiple splits is what it takes to be able to get all the views you need in this room for all the people who are in the room, which is kind of an amazing thing. So it's like being in mission control. Maybe Sophia can show the room.
You read my mind.
I love it. So you should hopefully be able to see in a minute us. Yep, you can in the room. We can wave. Hi, everybody. Tyler, don't you dare.
Yeah. You don't wave just yet, Tyler.
Later on, you can wave with Sebastian's hand. We'll give you the opportunity. But yeah, that's what it takes. Thanks, Sophia. That was awesome.
Anytime.
Yeah, totally mission control. So for those of you who are wondering what happens when we're not on shift, because there are a lot of us on this ship, and you only get one watch lead at a time up here, but there's so many of us that each watch lead really only gets an hour a day at most, and often less, because we're in the back running through samples, or working up our data, or running experiments, or contemplating looking through a microscope to look at the samples that were collected the day before. There is a flurry of activity that happens behind the scenes, and Falkor 2 has incredible facilities that enable all that. We have a wet lab, a seawater lab, a dry lab, another wet lab, and a cold room, in addition to some computer space that looks a lot like this control room but has sort of computer workstations, in addition to so many other things. So it really is just a very dynamic environment happening outside of the control room. So the control room is super special. And so is every other room of the ship. So if you were to peer in, you would get, a glimpse into the life of a geologist, a microbiologist, a chemist, physiologists, that would be me, and ecologists, morphologists. What else do we have on board? We have like everything. It's pretty amazing. Echinodermologists. I'm just kidding. What? Oh yeah, oceanographers, right? We have so many different types of expertise. You okay?
Yeah. I thought I plugged in an adapter here.
That I can
Oh,
do
who
it.
might have grabbed it?
All right.
That guy's great.
Sweet. Well done.
I bet he's got it. Good catch on that octopus.
Yeah, thanks.
All right. 3 of 6. Here we go.
Haven't gotten the one with holes in it yet, so hopefully it's this one.
So this, like all things in the deep sea, is one of those things where, I don't know if you know the story of the tortoise and the hare, but slow and steady wins the race. If we, going slow and steady here means that each push core is going to, really thoughtfully be picked up and placed where it needs to go. And the placement of this is important. You don't want to get them too far away. You can't get them too close, because when you pull them up, right, you need to be able to keep them independent. So the ROV pilots are doing a really amazing job of strategically positioning these cores so that we're able to get a sample that's as close as possible for cross comparison without disrupting the integrity of the core. And that is pretty cool. So we're going nice and easy. You can see, and even still, if you were to, it's pretty quick. And we're basically going backward through time with these push cores, right? Getting into layers and layers and layers of sediment, which these were laid down over millennia. If you think about what this sediment is, it's different than what happens on shallow beaches where, I'm sure I hope you've had the opportunity to go to a shallow water beach. If you haven't, please put it on your wish list. It's pretty amazing. But when the sand that you see on that beach is mostly the breakdown of shallow water calcium carbonate that is breaking down with wave action, right? So waves will break over a reef crest or nearby, and they'll break down a lot of the rocks and shells of sea creatures and turn that into sediment and sand, and that's what you get on the beach. This is different. The reason it looks so kind of soft and mucky is because what it is processed food that comes from the surface. And no, not food that was like grown in a garden. Ooh, you might lose your label. Oh, we got it. Okay. But it's, surface plankton and other surface organisms, for the most part, that have grown and have since either excreted or have died, and then they slowly fall in a process that takes a really long time. And as these particles at that point are floating down to the seafloor, you get what's called marine snow, which is so helpfully shown right here. Perfect for wintertime, at least in North America and Europe. But right now, or in the northern hemisphere right now, but you get this marine snow which falls, and as it falls, it's not a completely static process. You have tons of bacteria which will start to consume those particles as they fall. Other organisms will consume them and then excrete them, and then you'll have wow, I'm tired. Excrete them, and then you'll have more microbes which will glom onto them and sort of change their form yet again and yet again and yet again. And so this is highly used and reused and reused and recycled stuff, right? Particles, feces, dead animals, mucus, right? That has been used and has been microbially processed to some extent before it hits the seafloor, and it lays down over millennia. And when people talk about carbon sequestration in the seafloor, they mean lots of different things, but they partially mean this, right? All of this is a lot of activity from the surface or from shallower up in the water column that falls and lays down and stays there for the most part. And so with these push cores, we're able to kind of get that glimpse through history, which is pretty cool. And also, look at all this awesome carbon sequestration and marine snow that you see right before your very eyes.
These ones moved off to the left instead, so.
Yep. Nice.
Well done. Look at that. So if you're just tuning in, you might also see these two green laser lines. They are 10 centimeters apart, and they help us to calibrate size and distance, which is pretty exciting. It may not look so exciting at the moment, but it really does help every time we encounter an animal or a rock or really anything, sometimes ourselves. You must be glad to be back.
Yeah.
Yeah, it's good to see you. We missed you guys. What?
Gracias. Thank you. Good day.
Yeah.
This is a good day.
This is your first day out?
What's that?
First day back? First,
Yes.
yeah. It's a good day. So we have two co-chief scientists on this cruise. We have Dr. Jorge Cortez from the Universidad de Costa Rica, and we have Dr. Beth Orcutt from the Bigelow Marine Labs. And what's exciting is that Beth and Jorge did a wonderful job of planning these dives. So we have been taking these sediment cores. This is coming on the heels of a whole day of heat flow probe sampling across the sediment, which is literally transiting us from one spot to another that we need to go. So it's a really efficient dive plan because it kind of helps us move in the direction we need to move anyway, while getting some really important science done, and also, frankly, giving us a glimpse into these really cool habitats that we don't spend often enough looking at. Spend enough time looking at.
Alright, so we need to
Wow,
grab the
I'm
one-
really tired. My language is like, I'm slurring over words. You don't get a lot of sleep on a ship. So for those of you who have never done this, I'm actually doing pretty well this trip, which is amazing, but obviously not well enough. But they're what we call 24-hour ops. So 24-hour operations, which means that the ship is always doing something. It is never idle. We either have the ROV in the water, or we are transiting, in which case we are mapping and science is happening, or we are doing a CTD, which stands for conductivity, temperature, and depth cast, which means that we're sending Niskin bottles down to the depths with a bunch of sensors on them, and we're taking data from the sensors and filling up water at various depths so that we can look at water chemistry and a bunch of other water characteristics. So we are either mapping, grabbing water, taking data or samples with the ROV, and so we are just constantly moving. And then in the background of all of that, right, you have all of the experiments and the sample processing and the data processing that's happening behind the scenes. And then somewhere fit into that schedule, is the stuff of life: eating, sleeping. Basically, that's kind of it. Working out, hanging with your ship buddies, right? So it's a floating island, but it's a floating island that is constantly working, and there is not a single downtime moment. And often we're doing multiple things at once. So it's, sometimes it takes 2 years to plan an expedition, but then after 2 years of planning, you get 2 weeks of information that it's just incredibly powerful. It just really propels the knowledge of an area or on a topic, or in this case, 50 topics together all at once, which is pretty wild.
Then it takes 2 more years to write all the papers and PhDs on it.
If you do that in 2 years, then that's even more impressive. But usually, my first Falkor cruise was in 2017, and we are still publishing from that, right? And then we had one in 2021 during COVID, with a very small science team, and we're still working up the data. It takes a while. So some papers come out quickly, and some just take a little longer. It's like a slow trickle of science, and some things you start but can't finish on one cruise, then you need another cruise somewhere else to add another piece and then add another piece. And so, it's like a diverse portfolio of science that you build up slowly over time.
I don't see any orange on that one either.
What do you need?
Supposedly there's one with holes in it.
Yeah, that should be.
Do you want me to text Gus? Would that be
Yeah.
helpful? All right, let me do that. We are.
So it might just be take 6 regular.
Hold on.
Yeah, we had down there last night.
What's that?
Put it down there last night.
You did?
Yeah.
You don't know where you put it?
It was that spot. No, that's the first fold.
Yeah, did somebody take it out? Yeah, okay.
All right, we'll take a brief pause here as we try to figure out which push core we're looking for and make sure it's actually loaded on the vehicle because we want to make sure we get the right one while we're here. But yeah, back to previous cruises. This is like such a great ship to sail on, but I just, when I do cruises, typically it's all biology all the time with a little bit of geology that we pick up and send to off-ship collaborators, and it's all corals. But for me, I'm learning lots of new things on this expedition, and I think it's a really important thing to keep learning, which is easy to do in the deep sea because we know so little. There's always something new to learn, but also in academia, sometimes people get to take sabbaticals and they spend a half a year or a year in another university learning things from new colleagues and getting sort of a new culture. And this is not a restful sabbatical. This is chaos, right? It's not chaos, but it's like a constant run, right? Work all the way around the clock. But from the perspective of meeting new people and meeting new things and learning new things and getting exposed to new types of science, this kind of has the same sort of feel to it. There's nothing like ship life where you're surrounded by this diversity of scientists from all over the world, really, that are often together.
I didn't see, I don't know what it looked like.
So I've texted Gus, and I don't have an answer for us. You went to look for him? Thank you, Oda. So we're going to take one more minute, and then if we can't...
Just move that cap back over in case we gotta grab that.
Can you pull up the 5 that you have to save us some time, and then we can put another one down nearby?
Yeah.
I think that would probably be worth doing.
Okay.
And this way, when you pull them up, you'll see if one of them has holes.
Yeah, if we just, we could have just missed it too.
Right, so does that seem like a reasonable plan of attack here?
Sure.
Great, why don't we do that so we don't waste any time on the seafloor? Not that we ever waste time, because we always learn something, but this way we keep it going.
Alright,
So you probably wanna do number 1 or number 1 or 2 first.
yeah, give myself some more time to get that last one out.
Do you want to get them, the ones closest to the ship first so that they don't kind of spill over each other? I don't know.
You want to say
It's up to you. I was just saying, do you want to get, were you going for 1 or 2? Yeah, that's
they go
fine.
on the far side?
Yeah, exactly. Same page. Maria says we don't have those, so we can just put down a 6th whenever you're ready.
Oh, so we don't have the one with the hole.
Right. So you can pull, or you can put the one with holes down. It's up to you.
So just
Yeah.
grab the other one, number 3.
Yeah.
Then plop that one in
Yeah.
and start dragging it out.
Okay.
Okay. Oh.
Alright, so we have to just shimmy those caps around.
Let's do that.
So we're gonna. We don't have one with that has sort of a permeable barrier, sort of a sheath. So we're going to put 6 traditional push cores down and then pull them up. And the reason why it's worth time to come back and get the 6th is that then they're all in, and nothing from the push cores that we're about to go grab will fall into the holes and contaminate the potential push core we would like to take. Not that contamination from they're all from the same area, but you want to keep the integrity of the core so that the layers stay intact. So we are in the incredible waters of Costa Rica, and we have half of the science party is from Costa Rica, which is pretty incredible. So I've met a lot of new Costa Rican colleagues. What?
I didn't find him. But
Yeah, she said.
From Maria.
Yeah, exactly.
Okay.
She says. So we'll just take the normal 6. Yeah, exactly. Maria says, yeah, I got it. What was I saying? Yes, we are in Costa Rica. I haven't been to Costa Rica in a long time prior to this, but I trained as an ecologist in terrestrial Costa Rica in Las Cruces and Corcovado. It was pretty awesome as a grad student, and it's pretty amazing now to be in the waters of Costa Rica with so many Costa Rican colleagues. Costa Rica is such a cool country for so many reasons. The diversity of habitat is amazing, and they are really dedicated to ocean conservation and terrestrial conservation in general. And for that among the many reasons why they are going to be the host for the UN Oceans Conference coming up in spring of next year. And the whole world will get together in Costa Rica to talk about the fate of the oceans and the protection of the oceans and the importance of biodiversity and natural history and protecting rare and important species for us, for our planet, for basically everything. And so one of the things that this expedition and the June expedition are doing is laying the groundwork for the species that are here and the biodiversity and here in Costa Rica. I'm sure some of that will show up at the UN Oceans meeting that is coming up in spring of next year. So I really want to give a lot of credit to Costa Rica as a country, as well as our many colleagues who have worked so hard to describe the natural history of these waters so that we understand what we're protecting and why we should protect it, and what what's here, what they have, which is a big unknown, right? Even today, you've seen some new species, which will become, part of a record of biodiversity of the region. I think we're ready. Yeah. Go ahead. Do it. No reason to wait. There is already a large-scale marine protected area down by Isla del Cocos Island Marine Park, which is really exciting. It's a really remote set of islands in the Costa Rican EEZ. But this is a different set of seamounts, which are interesting for all kinds of different reasons. and have been explored for the past decade, but still, even with the relatively large amount of work that's been done here, there's really not a lot of work that's been done here. And so it's a chance to get this critical information so that we understand the history of the seafloor, the biodiversity of the animals, the seawater chemistry. And we've been working on hydrothermal springs, which are pretty cool. It's not a hydrothermal vent, but it has some chemosynthetic energy, but it's surrounded by, it's an octopus nursery, which you may have seen in our previous dives, and there's corals nearby, so it's an even more special opportunity for vent scientists and coral scientists and animal biologists who don't usually get together to be able to get together because of the uniqueness of this ecosystem. I mean, hydrothermal springs are pretty special, and there aren't a lot of them known in the world, especially not with octopus nurseries on them. So it's been pretty great to be able to have not just a diversity of life, but a diversity of habitat and a diversity of science happening as a result. It really goes to show how special these deep sea places are. I'm looking at this core, which is pretty stunning, right? You can see the change in sediment type. You can see the mud underneath, right? It's pretty cool. So see that white mud followed by the marine snow sediment at the surface. And that shows the transition between probably what's an oxic to an anoxic environment. I hope I'm right. Pretty sure, right, guys? Oxic to anoxic environments as you go from brown to white on the core. Yeah, I think so. Yeah, and so what you're looking at is seafloor history in these cores, and I always am struck by how ancient things are in the deep sea. You have, well done, one down, one in the pocket. And I think, a lot of people don't realize that life in the deep sea is very old, right? There are some of the corals and the sponges that we've been looking at live for over 100 years, sometimes over 500 years. It's pretty amazing. And what you're looking at right here is thousands of years, right? Millennia of seafloor history. And what this really means is that if you were to lose these systems, you can't regrow them tomorrow, right? That they've lived through 500 years of human history. Well done. And so it's really it's important that we study them, very carefully now, but also so that we understand whether or not they're likely to survive the next 500 years of human history. And when you think about 500 years of human history, it's just an incredible amount of change that we've witnessed, right? Industrial revolution, like birth and death of many countries, multiple wars, just a completely different time. Ooh, nice. And so, these animals have been at the bottom of the seafloor, but have, been alive for all of that history. And so they're very irreplaceable when we think about what's at stake in the next few years with the way we're changing our climate so quickly. So it really is a very important thing to get a baseline for how these animals live now and hope that it stays just as stable and just as intact for the many hundreds, if not thousands of years to come. Really, the only change should be tectonic change or hydrothermal change. It shouldn't be from us. All right, one push core in. The depth perception on this is really tricky. It's really hard to see where you are. The pilots that we have are unbelievably skilled at being able to assess and evaluate where to grab. And they're doing this. I know you're looking at just one screen, but again, we've got 22 screens in this room, and a lot of them are showing us different angles in the ROV that really help the pilots to be able to triangulate and figure out where to grab. But it's not an easy thing to simultaneously take in and ingest views from multiple screens and then be able to, in real time, right, manipulate the robot to be able to perform a function on the seafloor. there's a single coral. I don't remember where in the world it is, but it's over 4,000 years old that lives on the seafloor. Isn't that amazing?
That is amazing.
And then there was a sponge that was collected in the South China Sea that was estimated to be 18,000 years old.
Wow.
Unbelievable.
Yeah. That's amazing.
It's amazing. I mean, we're about to. I mean, just 2,000 years is like, we're in 2023
Yeah.
AD, right? And that's 2,000 years before that.
Oh yeah.
It's really amazing. So, there's a lot of living history here. And so one of the scientists on the ship, Maria Sandoval, is looking at radiolarians in sediments, which are really cool because they are really good markers of climate reconstruction history on the seafloor. And so she'll look at these cores and get a sense of that. And by that I mean, what did the climate look like? What fell from the surface? What is the sediment composition? What was the marine life like, right? How did they calcify? What is the abundance of these organisms? What does that tell? Like, what are they made of? What does that tell us about the chemistry, right? So there's a whole lot of information that can be gleaned. I have had the honor and pleasure of sharing island space, but not ship space, but with many as sort of climate reconstruction scientists, many of which study foraminiferans, which is another little critter, and there's a whole bunch of other things that people can look at, and it's painstakingly, small and careful work, but if you do it right, you can, especially with this many push cores taken from a single area, you can get a whole lot of information, geological, chemical, biological, physical, about how the seafloor has changed over time, and that is awesome, right? Think about how many, if you wanted a time machine, this is it. This is a deep sea time machine. That's what we're doing with sediment cores. I love it. Deep sea time machine. Say that 10 times fast, Toter. That's hard to say.
Deep sea time
I just called you
machine,
Toter
deep sea
instead of
time
Tomer.
machine.
Sorry.
Deep sea time machine.
One more time.
Deep sea time machine.
Keep going.
There you go.
Deep sea time machine. Deep sea time machine.
It's you see, you can't do it. We just invented a tongue twister. Deep sea time machine. Can you do it, Theo?
Probably nudge that.
Say deep sea time machine 10 times fast.
Be careful, you want to not be.
I can't do it.
Exactly. Yeah.
Tomer can't do it. Maybe you can.
Give it a shot.
It's like a tongue twister. I know. Maybe you can do it in Spanish. See if it's still a tongue twister in Spanish. So that's what this is. We have a deep sea time machine that we are using to go back in time and figure out what happened on the seafloor.
I think that's smarter. Okay, let's get this up. Alright. And that's going to be one of the ones in the front here. I think it's this one right here. What's this one? I think so, yeah. Alright. Someone's behind me. You can see it pretty good in the upper as well.
All right. So we have 2 out of 6 push cores in, and we've got a shift change coming up. We're gonna have Claude on the hand. Or you don't know where you're gonna be yet.
Clawed on the claw.
Claude on the claw. That's another one. Look at that. Look at us. We got the language on a roll today.
Clawed on the claw.
Hi, Jorge. Are you gonna take shift? All right. Well, it has been a pleasure to chat with you all today. Always an honor to be in the control room and to hang out with ROV pilots and do some work on the seafloor. But I am going to turn this over to my very esteemed colleague, Jorge Cortez from the University of Costa Rica, who's also one of the co-chief scientists of this expedition. And he's going to finish our push core Odyssey. Have a good time. Thank you.
Hello. Hey, how are you, buddy?
Good. How are you?
For an hour.
Muy buenas tardes o buenas noches, buenos días. Les habla Jorge Cortés de la Universidad de Costa Rica y vamos a continuar terminando de recoger estos núcleos y tenemos todavía sí, una media hora más de trabajo aquí. Good afternoon, good evening, good night, good morning. It's Jorge Cortez from the University of Costa Rica. I'll be here for the next half an hour. I'm going to finish picking up this push course. And the idea of this push course is to bring up sediments to study what's present in there. And we'll be finishing this dive in about a little over half an hour.
Okay, if you want to go, you type it. It's okay if you like. It's up to you. No problem.
All right.
This covers it.
Push course.
Strategy of this, right? Does it look like it's for like the left back ones and the front ones?
Doesn't really matter, but normally just, if you do those, all you have to do is rest things in these empty spots. So you take it out, you drop the 3 right here, take the 3 out, drop the empty ones in there.
Okay.
Do
I kind of saw something like this the other day when I was watching, so I didn't know if this was the way to go or not. Alright. The piece of tape that's missing on number 2 right there, I'll probably just lock this on. That's all.
Gracias.
That's it. Cool.
doing after push course?
Almost done. Those last 3.
Yeah, what are we doing after?
We just move, see if we see something interesting
What do you want to see?
to collect, and we'll be over in half an hour.
What do you want to see? What do you think is interesting?
Let me check the priorities here.
Starfish?
Yeah, we'll see if there's sea cucumbers or
Sea cucumber? Y'all looking for the yellow one?
let me ask. Yeah, there's supposed to be. Aquí está. ¿Qué buscan de equinodemos? ¿Qué falta?
Dos pepinos de aventuria, aventuritas.
¿Cuáles son? Bueno, sí. Vamos a movernos y veas algo de.
Confused. Out of the first time I did.
Bueno, ahora ya tenemos cambio aquí de pilotos. Tenemos ahora a J-Rod, que es el jefe de los pilotos del RV, como piloto, y como segundo piloto a Claude, y en la comunicación al fondo a Sophie.
Ooh, they're not in yet.
Oh, that's not Claude.
If they
That's
don't
not-
go in, it's his fault.
I'm predicting Claude. Ace this. Sweat.
Alright, you ready? Alright, let's go for 7. I think it's that one, right?
Yeah, second would be
Yeah, that one over here, yeah.
this one. That is one.
Yeah.
This is the back, right?
Yep.
So we'll just, when we're done with this, we'll just move and levels here, so we see specific sea cucumber, we'll go for it.
Do you know which one it is?
¿Cómo es ese pepino?
Is this the yellow one?
No, one, the yellow one.
And then the flat purple one?
Yeah, the purple one is one that has some filaments.
Yeah, the one that we suctioned up the other day?
Yeah, exactly. Yeah.
Except this time, no.
The yellow one is more like green one.
Yeah. You want those two?
Yeah.
Okay.
Okay. Do we see that?
We'll find you one of those.
And if we are able to see any Aztecs or Amperima or Penigoni, I will tell you.
Okay, those ones, I don't know them by that name.
Me either.
If you show me an example,
Yeah.
I'll find it.
Uh-huh. And you saw the Medusa yesterday?
The Medusa
With
jellyfish?
that had a lot of dots inside.
Yeah.
They're parasites.
They were parasites, okay.
Yeah, I sent it to a guy, a colleague
Yeah,
in Italy.
I've never seen that before.
No. And so if when we're coming up, if we see that, yeah, please.
Can do. Yeah, remember that guy? And the one that kind of looks like that, the darker purple one.
Y podemos ver en estos núcleos de sedimento un cambio, en la parte superior unos sedimento fino de color café
Pointing it at us, right?
y abajo más claro, blanco, y por los estudios que ha hecho la doctora María Isabel Sandoval, que está aquí a bordo, esos son sedimentos muy antiguos, de hace unos 15 millones de años.
Have a little bit further before you drop it. Yeah, get to a bind before you drop it.
Ya que vemos ese núcleo,
There you go.
ahí ya. Yeah, these cores have 2 sections. The top part's brown. Those are pelagic sediments that come from the surface, and the other ones are very, very old, 50 million year old sediments, the white part. Uh-huh.
They're sitting on acres.
Mm.
The backside. You don't want to wrap around it like that. Neck around.
Good.
This one closest to it. Yeah, shoulder. There's something wrong with that shoulder.
The sediments were dated by looking at the microfossils in there, specifically the radiolarians, which is the specialty of Maria Isabel. She did her PhD working with radiolarians from the Miocene, and so when she saw these sediments in June, could identify right away that these are very, very old sediments. Han preguntado cómo sabemos la edad de esos sedimentos y como ya habíamos estado aquí en junio, entonces tenemos ya colecciones de aquí y María Isabel hizo análisis de los microfósiles que hay ahí, específicamente radiolarios, y se dio cuenta que hay radiolarios, los radiolarios corresponden al Mioceno, que es el periodo que ella estudió para su tesis doctoral.
Grab it. You don't have to grab it 90 out. You can get a little bit 45 if you want to. There you go.
Mm-hmm.
There you go. Doesn't have to come straight out.
Hmm.
Just go straight in. Doesn't have to come straight in.
Interesting, all the sediment that it's bringing up. Ah, that's very sticky.
Very steep. Yeah, it's best to almost just bring your yaw all the way over to the other side.
dictates how sticky the sediment is?
How?
What dictates how sticky the sediment is? I'm just curious.
Yeah, how sticky the sediments are, that depends on the composition of the minerals that are present, the amount of water that they have,
In that one that you're over right there.
and that makes a difference. Some like the top ones, the brown ones, are very loose sediments. These ones are more compact, so that also makes it stick more. Se han preguntado por qué algunos sedimentos son como mucho más pegajosos que otros, como estos que estamos viendo, y la razón es que depende de la composición de los minerales que tiene y cuánto agua tiene y qué tan compactado está también.
You see, so there's a reason why you don't push them all the way down in the mud, because you want to leave a little gap of water right there. And when you push them in there, you're pushing on the bump, and so that fills up some of it. If you don't have enough, you push that level there, and it messes up their top layer. So you did perfect. There's still a gap.
Perfect. Thank you. Yeah, I saw some of them were a bit all the way down.
Yeah.
So yeah, it's a problem because we lose the top, which is the most interesting part.
Sorry, I can't bring the function. Get the same bits up there.
Today have been a sediment day, all day long. We did push heat flows by Andy Fisher from the University of Miami, and this is measurements are to see how much heat is moving through the sediments from the lower levels of the seafloor. Now we're collecting these sediments for other complementary studies. Sí, hoy todo el día fue dedicado a los estudios de sedimentos. Durante el día estuvo el doctor Andy Fisher de la Universidad de Miami, la escuela de Rosenstiel, y estuvo haciendo estas mediciones. Entonces consiste en una varilla que se entierra en el sedimento y se ven cambios de temperatura a diferentes niveles. Son sensores muy sensibles y así se puede ver el flujo de calor desde las capas más profundas del suelo hacia la superficie. Para los que se han conectado recientemente, aquí estamos a 200 kilómetros de la costa de Costa Rica, en el mar Pacífico, a 3.000 metros de profundidad, estudiando varios montículos submarinos que tienen una característica, dos de ellos muy especial, y es que emana un agua caliente, y a donde sean esas emanaciones hemos encontrado pulpos incubando sus huevos. Solo se conocen cinco sitios con esas características alrededor del mundo.
It's challenging when it's good when you first come to it.
Good.
Or not normal.
If you just tune in, we are here in 200 kilometers offshore Costa Rica on the Pacific coast, and in a series of low mounts at around 3,000 meters depth. And what's special at this is that warm water is coming out, and the female octopus lay their eggs there. Some general information about Costa Rica. It's a small country in Central America with a very large marine area. So 92% of the country is sea. And that sea, that large marine area, most of it is very deep waters. And it's just in the last couple decades that we have started studying these deep areas of Costa Rica. We'll be developing a campaign called The Unknown Costa Rica, because we know very little about this. Costa Rica es un país en Centroamérica, pequeño, pero con un área marina muy grande. 92% del país es marino, y de eso un porcentaje muy alto, un porcentaje muy alto es zonas profundas. Es lo que hemos llamado la Costa Rica desconocida. Yeah.
controller. So if we swap controllers, we'll find.
Maybe we have just
Definitely got quiz from nice quiz that.
I was just using it the other day to get hot. I can still eventually get it going. This is.
Yeah, that's what that when it reaches, that's where it starts coming up. That's where it stops.
You know what we could do is we could just
Swap it and see.
yeah. His arm's gonna drop. No, it's down here. It's down here.
So I take off the controller.
Let me get this one. You could do the starboard.
Take off right.
Yeah. It drops. Okay. Yeah, that one's gonna drop, but it's okay. Track and roll the one we have.
We were having some technical problems, but
You got enough items
Alright.
you need?
ready to continue. Tuvimos unos problemas técnicos, pero ya vamos a poder continuar. Good.
Right there.
Does it seem like it's giving a wrong command too?
No, it's giving the right command. It's just not enough of it. It's just the shoulder or something that's messed up. I'll just leave it like that for now. If you want to swap them one more time, we'll just fix that later. How much time we got?
Yeah. No, it's
Time is over.
time is over.
I'm sorry.
No problem.
See if we can't get this fixed. Alright, so start coming up.
Yeah. So we see something interesting. We see that jellyfish for sure.
Which, oh yeah, that jellyfish.
Yeah.
What about the Japatella?
No, we got plenty of those. And there's also a request for a Niskin bottle, very close to the surface.
Okay. Like yesterday?
Oh, that's the label down there.
Huh?
That's a label.
Yeah, my arms are dead. I pick it up and my arms are dead.
Yeah.
Thank you, Medusa jellyfish.
Yeah, I guess yesterday you sampled one of those near the surface. Huh?
Bridge. That's RV off button.
Cobra.
Yes, that function is what broke when it fell. It snapped right there. I managed to get it back together, but all the stuff inside there is all messed up. And
Hold on.
they have nothing. What's wrong?
I'm not in a hurry. It's only a head.
Jorge, would you like to sign upstream or would you like me to do
Okay.
it?
Well, you can
I'll do it.
You take the curve.
Bueno, muchas gracias por acompañarnos hoy. Se despide Jorge Cortés Núñez de la Universidad de Costa Rica. Y ya vamos ascendiendo. Hoy va a ser un par de horas
Okay, then stow this one.
y mañana continuamos. We're done for today, going up to the surface. We're done for today with the dive, but still work to be done up here. And we'll see you tomorrow. This was Jorge Cortés from University of Costa Rica. Bye-bye.
you.